All right, so hi, good morning. Um, Apologies about yesterday. I was pretty much dead. I couldn't move, but we're going to try to power through it today. So long as I can talk, I will try to keep this going for as long as I possibly can. As long as I'm not coughing and I'm able to keep a good voice, it should be okay. Is the volume doing well? I'm seeing people already chatting, so that's good. How are you? Just going to get some early testing stuff going out first, and because this is new settings for this. So hopefully people can hear me. Yeah, I can tell that. That's yeah, right. Yeah, I can tell that. Yeah, definitely. Okay, so that should be going out. Slightly different perspectives on things, but just like the monitor view and just my chair, I think. But I might have to look here sometimes, which is like the mic. It's annoying because I have to use like all three screens today. I think have to keep up with the chat, the Q&A session, and yeah, I have to keep up with this one. Yes, well, okay, that was the question I wanted to answer first off. So, what I'm going to do is, which I'm doing right now, record as well as stream. I'm probably not going to keep the lecture on the actual channel, but I probably will put it onto YouTube. I'm not going to require you to go to YouTube. That's against their social media policy, but I will also upload it to It's Learning. Um, what I will end up doing is starting a fresh OOP lectures from chapter one, and then keep those on the channel. But starting from chapter four might confuse any person that's not a student in here. So I figured that it'll transition over. That way you have them in three different ways, I think. But I will keep it for a little bit and then let it expire, but I will publish it privately, probably to YouTube, and I'll give you the links for that and put it on It's Learning, and then start up a new. I'm going a little bit too much. Start up a new session of educational content on Twitch. Sound good? I think that answers that question. Cool. All right. So I guess we can see we got 33 viewers. I think we got a decent amount of people. People can trickle in. I'm going to start with like a recap of what we've looked at for so far with the relationships between classes, and then I'm going to go into how do you actually decide what the relationship should be. And depending on how far we get past that, I may or may not go into inheritance. I will see how. I mean, it's a long stream. This is the most time I've gotten with you guys all terms, which is crazy because I'm not even there. You know, I miss all the FaceTime that I usually have with students, but it is what it is. But yeah, I thought I would start and go from the beginning here. Just a quick rundown, though. And that basically, this whole chapter is about how to connect different objects together, or if you want to say classes, either way. Because at this point, they're sort of intertwined, both classes and objects. So what we're trying to determine is, well, you have definitely more than one class that you're going to be working with. How do they work together? And there are a few different types. We're going over at the very least two and how they work in implementation phase. And that is going to be the has, a, and part of relationships, which are the association and composition relationships. So again, classes can work together. I'm going to go through this a little quickly since I gave this lecture already, but just to give a recap. So they can work together, but the thing is, we've been looking at everything from the real world from the beginning of the term, and that's great. But the thing that doesn't really follow you to code is the relationships between things. So if you have like, father, mother in the real world, that relationship doesn't follow you into code unless you specifically tell it to. And you don't have to necessarily define it in that way. So it may make sense for that particular example, but there may be other relationships that you want them to have depending on how much flexibility and security you want. So you get to choose. And defining how things connect is a big part of what you do as a programmer, especially as an object-oriented programmer. So the ones that we'll see today are association and composition. Um, and I'm just going to give a small update on that. Yeah, so association, that one has a relationship. Basically, it's very simple. We can look at it here. Um, Inventory has items, right? So that would be a one-way association. So in order to actually get in the association in UML, you draw a line with an arrow. And in order to get it into code, you can see from the UML that you have a simple list of items in the inventory. And you can do something, you don't have to use that particular data structure. You can use dictionary or others, but you do need to have some reference between your inventory and your item. That's the way they connect, by having a reference to them. So this references it through a list. And association has two directions. It can either be one way or two directions. Actually, two different types of directionality is the actual proper way to say that. You can either have a one-way, unidirectional, or you can have bidirectional. Most of the time, we are dealing with unidirectional things in our classes, which is good because it makes it a lot easier to update things. There are times when it doesn't work so well, and that's times like doctor and patient that we see here. Now, both the doctor has a list of patients and the patient has a list of doctors. And the reason for that is that patients can see multiple doctors, and doctors can certainly see multiple patients. So that relationship makes sense in this context. But if we change anything about these classes, we have to make sure that we change how the other class works as well. So we have to make sure those references actually still stay. And that's the part where it gets to be difficult with bidirectional associations. So we try to avoid them where we can, but it definitely does make sense in some contexts, especially like this example. Now, for using, we use a coffee example today. I'll go through that in implementation phase as well. But basically, on this particular example, we're having a coffee that is in a coffee shop. We'll say that we're modeling a coffee shop. That's our problem. Okay. Well, a coffee shop has many things. You can say it has a kitchenette, it has pastries, it has, obviously coffee and sometimes tea, and has different types of coffee, and it has workers, and it has inventory and all that stuff. But we're going to start very, very, very simple and say that we have a coffee and a barista. And that's very simple to start with. And we'll eventually add on to that. But basically, to have a coffee and barista, we need to figure out what is the relationship between those two. And we could think that maybe we want to say the barista tracks every single thing that they ever made. But that would be a difficult relationship to maintain. First of all, you would have to go to every employee you have and say, oh, well, did you make that? Let me see. So it would be a difficult thing to actually get the information from, and it would be really weird to have it actually listed that way. So we're going to have a coffee, which is again, I'm not saying this is even better, but it is what we're going to do at the moment. We're going to have coffee track who makes it. And eventually, what I would say is that you would probably more likely have an order that tracks who processed the order. You could go simpler and say you have a menu item and who made the menu item. You can do that with a little bit more abstraction, but we want to get a bit more concrete right now and say, okay, we have coffee, we have a barista, the barista made the coffee. This is what we have. This is our relationship, our unidirectional relationship. It looks very similar to the UML. We just have the barista right in the coffee, and we don't have anything in the barista class that says anything about coffee right there. So there's only one way relationship between the two. And on a bidirectional, this is where we have the coffee house in play, which I was mentioning, that we can go a bit more complex. Well, this time we want to be able to track all of our baristas or people who work for the coffee house. But we also want the barista to be able to track where they work to get their schedule and things like that, So they need to be able to know information about their workplace, their specific coffee house that they work at, and most likely just their schedule, but also like paid, things like that. But the coffee house needs a list of its baristas. There are other types of employees, but for coffee house, barista is the most typical, so that's what we're using. And it has a simple way of doing that. It has a list of barista and coffee house, and it says a single coffee house for barista, which means that coffee houses can have multiple baristas, but a barista can only work at one coffee house. That's not always the case. You could actually have a list of coffee houses that they work at. That's certainly a possibility if you want to model the system that way. It depends on the context of the system that you're actually modeling. I'm trying to keep things just a little simple here, but you could have something different in mind, and that's perfectly fine. Just so long as you're modeling it realistically as you understand the problem that you are modeling in the real world. Now, the one directional, simpler to maintain, less error prone, and used where possible. The bidirectional, complex, requires careful updates. You have to update both classes and use only when necessary, but there are definitely times where it is necessary, which is why we learn it. The other type of relationship, and as I said, I'm going through this quickly because we have already done this, but I wanted to do it as quickly as I could through this and just give a recap. The other type of relationship that we're dealing with for right now, and it's more of a it's it's a has a relationship, but it's called a part of relationship. So has a in the title, I would say part of should be the better description. It's a subclass of has a, but we'll say it's part of because it's most linked to that naming convention. So a part belongs to a whole. You can say the plane has wings. You can say the human has a heart. You can say a tree has branches. So the parts belong to the whole, and the parts can't exist alone. Typically, you can have a heart transplant and things like that, but generally speaking, the part doesn't exist without the whole, and the whole controls the entire life cycle of the part, meaning that it creates it, it manages any updates to it, and it destroys it when necessary. Most of the destruction phase is done automatically. You usually don't have to worry about that, but creation and management definitely have to worry about. So here's an example. Computer and processor, and again, you can think of this in more than one way. You can think of, okay, a processor is swappable. But you could also say, well, a computer stops to be functioning as a computer if you remove the processor. If I remove this processor right now, then we're not going to be talking anymore. That's not going to happen. Even if I try to do a hot swap real quick, yeah, that would not happen. So this is a composition relationship in that aspect. If you work for a machine factory that actually makes computers and makes processors, at that point you might say, well, this is a part we can easily interchange with others. And at that point, you might be right. That's fine. Again, it depends. Context is a big deal here. But in this case, I'm modeling this as a composition to show you that one thing can be a part of a whole. And to show that in UML, you use the filled diamond towards the whole, which is the computer. And you'll notice that the computer has a processor, but the processor doesn't have a computer, and that's pretty much the way you do it. It's like a unidirectional, again, composition is fully unidirectional, so it just goes to the whole. The whole can be full of small parts too. So you might get like list of processor and RAM and things like that, and disk drives, that sort of thing. In code, it's not too more difficult than what we just looked at. We can have, for instance, here we have a parent that creates the parts. We can see that the coffee house here has a menu item list, and it's creating the menu items. The menu item itself is internal, meaning that no third-party developer can really access it. I'll get more into what internal means today when we get to access modifiers. I'm pretty sure we'll get there. But basically, the simplest way to understand it at the moment for you is that it prevents third-party developers from accessing it. So for menu item, this says to a developer, okay, well, this is meant to stand on its own. It cannot be used elsewhere. It has internal access only. You cannot access this outside the coffee house. The coffee house has full control on this. So you would never use a menu item outside the coffee house. In this case, that is showing a composition relationship. You have a private list of menu items, and that is created when you call the add to menu. Nothing, there's no creation otherwise. This is the only thing that's going to create a new menu item is by adding it to the menu. You wouldn't call the actual constructor for menu item. And as far as the pros and cons, association, well, you got independence. They're very loosely connected, and that maintains a really high flexibility, which is very good whenever you are working with very disparate classes, especially when you start a new project. Having everything tightly coupled, tightly bonded to start with is a very difficult thing to move away from. It's nice to start with the flexibility that you have and then tighten it up as you need. They can exist separately, but composition does have strong ownership because the whole owns the part. It has a very clear life cycle, so you know exactly because that owns the part, you know exactly when that part is created, who manages it, what's going to be done with it. And it obviously has better protection because it's completely encapsulated by the whole. So that's a good thing to have, is more better protection. It's usually a trade-off between security and flexibility, and those two things you have to keep in mind. So again, objects work together. You have to decide that. So they don't just follow you from the real world. You have to figure out, okay, well, I am the developer here. So how do my things work together? How do my objects work together? How should they? What is it like in the current environment that I'm modeling? Talk to your stakeholders, talk to the people that work at the places that you're modeling. You'll get to learn the infrastructure of that place. Before you ever start writing a line of code, you can start designing, and then you eventually get to the code. And then choose based on, sorry, it's going to happen every once in a while. It's going to be, I still have, virus and all that. Let's try to get some water. It's going to happen every once in a while. I know it is. But I think with the water, it'll be okay. But yes, choose based on the needs of the actual project that you're working on. I think that's the end of this particular slide, and I'm going to go first ask if there's any questions from this particular one, which we did go over last time I was there, but just in case. So are there any questions from this? And I would like to get out of that so I can see a little easier from the chat. Let's see. I'm going to refresh the discussion forum too. I can't keep too much of a track of everything, but I'm trying. Oh, great. So apparently if I refresh the discussion forum, it takes me out of the discussion forum. So, but no, there's nothing on there. I don't see any particular questions at the moment. Everyone's being nice and quiet. So hopefully you got through that little part. But again, it was a recap. So the rest of it's going to be a little slower. I was just going through it quickly because it's a recap. And I will continue to take breaks as needed, but I'm going to try power through. But okay, so yeah, I think I want to at least start the next one before we do any breaks or anything. We've only been going 20 minutes after all. So I will go ahead and start. I made one specifically for 4.1.3. And the thing here, the reason I made this for 4.1.3 is that this particular one says how do you actually decide what your relationships are, because you can learn how to code them, and that's not an issue. You can say, okay, well, this has a connection to this other object because I made a reference through a list. Or I may reference by just putting the name of that class in a variable. So, okay, that's a reference. You can do that in coding, but how do you determine whether that reference should be there in the first place? That's the real question. And that's really where I want to start today and what I want to focus on. I developed a framework myself. There are frameworks available that are long and complex. I tried to simplify it as much as possible to get the most important questions that you possibly have for deciding how you actually get objects to work together. So when we create objects in our model that model real world things, we have to decide how they work together. In the real world, coffee and the barista are connected. Baristas make coffee. But in our program, we have to specifically say that the barista makes coffee. So we got to figure that out. And again, that's just part of the recap of the last time. How do we decide, though? And that's what's coming up. There are four key questions that I came up with to for this framework. That I thought were crucial for determining whether or not one relationship is appropriate over another. And there are other relationships that we'll learn about later on, but they still fall under these four questions. So the first question is one object part of another? And I'll explain them each after I have slides for each of these. So, and can one of the objects be replaced? Do the objects share common features? And then what is it that you're solving? What's the actual problem, the real world model that you're building? So let's start with is one object part of another? That's the first question we generally ask. In our coffee house, we can think about the menu items. They're part of the coffee house itself. You can't take a menu item from the coffee house and use it as anywhere else because the prices and options are specific to that coffee house. Now, you can think the barista. The barista is not a part of the coffee house in the same way. They can work at different coffee houses or even change jobs and completely not be a barista anymore. You can also think about a music playlist that we've looked at those several times. The order of songs is part of that specific playlist, but the songs themselves can exist in many playlists. So something I'd like you to think about is a comment part of the post that it's on. If you're making a social media post, is a comment part of the post it's on? Is your phone's battery part of your phone? And what happens to files when you delete a folder? So think about those things whenever you're deciding whether or not you think one object is part of another. Look for can it exist on its own? Does it only make sense as part of something else? And what happens if we remove it? So, can objects be replaced? In this case, you can certainly replace some things, right? There are some times where you can place things, sometimes where you can't. If we say that we use our coffee house example, a barista can be replaced by another barista, and or even for a different shift. So the coffee house works the same way. But if you replace the entire menu, it would be a fundamentally different coffee house. Now, sometimes they restructure and things like that, but it would be fundamentally different if you have to go that route. You can also think of a music streaming service, for instance. You can easily change what songs are in your playlist without changing the playlist itself. So on these, I would like you to think about if you can change your wallpaper on the phone, is it the same phone? If you replace the songs of a playlist, is it still a playlist? Is it still the same one? And can a message be shown in different chat windows? So consider, does replacing it change the whole object? Can it be used somewhere else? And is it able to be swapped out or replaced. Those are the things you have to think about whenever you're deciding the relationships. So, the third question is, do the objects share features? And this is more of inheritance that we get into later on. But sometimes different things have different common features to them. In our coffee house, for instance, I'm going to use this throughout, all our drinks share certain features. They all have a size, they have a price, they can be ordered. So they have all these things in common. They have flavorings you can add and that sort of thing. All hot drinks can be heated. All coffee drinks contain coffee. So understanding these shared features helps you organize the code better. And similarly, in a messaging app, all messages share features like timestamp, sender, and content. Now, for this, I would like you to think about what do all the drinks in a coffee house have in common? What are all the different things that they actually have in common? I only named a few. What do all types of messages share? And what features do all digital photos share? In this case, you need to look for common characteristics, shared behaviors, means shared methods, or even shared properties, and natural groupings. Sometimes things be categorized into different groups. So those are things to look at. And if this actually goes to the next one. So, yes, finally. Okay, it didn't change on my screen. All right, so what problem are you solving is the last. So finally, we need to actually think about what problem we're solving. In our coffee house system, we're tracking orders, we're making drinks, we're managing barista shifts, all these sorts of things. These needs are going to influence how we connect things. If we were building a different system, like one for ordering supplies, we might connect things differently. If we have a different way of thinking about the coffee house, if it's just a simple, like one station coffee house, not a franchise or anything, then it might be a much simpler connections to make than if you actually have a franchise of coffee houses that you have to manage different inventories at each one while keeping a consistent menu at each one, and then maybe varying prices by area depending. So these needs influence how we connect things. It's like how a photo sharing app connects pictures and users differently if they than a photo editing app does. So for this, I'd like you to think about how is a music player different from a music store? Why might a coffee house track different orders differently than a restaurant? Why might a coffee house track orders differently than a restaurant does? And there's good reasons for that. And how might a ride service connect drivers and passengers differently than a bus service? So think about those things and consider what is the main purpose of the problem that you're solving? What needs to be modeled and tracked appropriately? And how will objects be used in your system? So, what do we actually do with these? Well, if we find that it actually is the case that it's one object is a part of another, then we might consider composition at that point, tightly bound. If we find that they're more independent, then consider association. If they can be replaced or reused, then consider association at that point. But if they can't, like human and heart, things like that, wing and plane, those sort of examples, if they can't be replaced or reused without fundamentally changing the whole, consider composition. As far as the shared properties or behaviors, if that is the case, consider inheritance and more advanced relationships that we'll get into later. But otherwise, then we can look at association and composition. Usually, if you're looking at inheritance specifically, and say, well, there might not be enough in common, but there seems to be a strong relationship, then you look at composition instead of inheritance. And you don't always go directly to dissociation, unfortunately. What real model world problem are you solving? You use this to validate the choice that you're making. This lets you know whether the first three are accurate. Is this really the way you're modeling it? Is this really the way you should be modeling it? It may override other considerations that you have. These are not specifically in any priority list. These are not saying, okay, one is answered, so yes, composition, and don't do 2, 3, or 4. That's not the way this is working. This is saying consider this. But let's look at the other properties too. And you have to keep that in mind, and you have to figure out, based on all of that, what fits it best. And it is subjective sometimes. And you have to make that subjective consideration. And of course, you'll have people that you can talk to. You'll have your bosses, your coworkers and things, and you'll have your stakeholders that you can reach out to. And the context obviously matters for what system you are modeling. Very much if you're working with a healthcare system, that context matters an extreme amount as compared to, say, a coffee house. You're talking about people's lives at that point, right? So your model of the healthcare system better be accurate. Okay, so those are what I want you to think about. We're going to take a little bit of a break here, and then I will start to look at implementing a coffee house example and saying, how are we going to actually model this thing? But for now, I will take a short intermission. If do I even have that set? Let's come back. There we go. All right. So I'm going to get some music that Twitch is actually okay with for my breaks at some point. They still have not been happy with anything I try to get there, even though I go for royalty-free stuff whenever I do the break stuff. The other stuff is mine, but that's probably why they let me do it because it's my stuff. But the Be Right Back stuff is royalty-free music, so meh. But anyway, I am hoping that you are coming back for some more implementation at this point. We have now discussed relationships for quite a while, association and composition, and we got a little bit of inheritance. We'll get more of that probably. But I would like us to actually solve a problem. I'm going to be using VS Code today. JetBrains Writer now has a free plan. If you want to use them, that's fine. Or whatever IDE you choose, that is perfectly fine. But some of the way I do things may be VS Code specific. That's just about it. It's like typing .NET Run, for instance. Um, but so use if I say I'm going to type .NET Run or .NET New Console, then make a new console app using whatever your IDE is, or run the program using whatever way you run programs in your IDE. So I'm going to start out and open a folder. Just create a new one. Call it, oh, let's see, nothing else. And there we go. Open this guy up. Yeah, yeah, there's nothing in there. I thought I hit open file, didn't I? Yeah, open file. Let's hit Control K. Yeah, the problem is it says Control K, Control O right there, but it doesn't actually mean that. Let's just do it that way. There, we need to open the folder. All right. And now we can close the welcome screen, which opened for some reason. So we now have an empty project completely, and I would like to start out with a console application. So I'd like to do that from the terminal, and I will go to Terminal and New Terminal. From here, it's a simple type of .NET New Console to use the console template in Visual Studio Code. .NET New Console. Oh, and you should see some things pop up. An ops directory, a C# project, which has a bit of information in XML format, and some top level statements that I will immediately get rid of. Um, since it's the program.cs class, it's kind of the main program class, I will put the requirements for the problem here. So here's what I've laid out. Let me see if I can get this. All right. So we start out, and let's just do this. Yeah, okay. So let's say step one of solving a problem is always to understand the problem. Understand the problem. And to do that, you reach out to stakeholders. Your boss will probably put something in your lap. That would be some way of doing it. And you reach out to your colleagues and coworkers, anyone that has any information about the problem that you're solving. And of course, you do your own research as well and use the research scientists have done many, many years. All right. So requirements for this that I've set out. So these are mine. I'm like your boss today, I guess. But the requirements I set out are that, let's say, a coffee house needs to track its menu items and drinks being made. And that's the first requirement. Okay. Menu items belong to the coffee house. All right. And then we have baristas work at the coffee house and make drinks. Simple enough. By the way, I should probably do this. And let's say each drink should track which barista made it, which is the way we described it earlier. All right. And then we'll need to be able to do a few things. So need to be able to. And at this point, we want to be able to add and remove menu items from menu. And we want to be able to make drinks from menu items. And we want to track which barista made each drink. And we want to show all the drinks that have been made ever. Just for, information purposes. This would obviously just be an internal thing. Okay, that's kind of the idea that we have. We have to think about, what does this actually look like? What are the relationships here? So the menu items belonging to the coffee house. Does anyone have an idea of what relationship that might be? I'll wait for an answer. If you don't give me one, I'll give it to you. It's fine. I'm curious if anyone's going to like talk. I have like 49 viewers at this point, so someone's got to say something. Can't be the only one talking, right? Unless you guys are just listening back in bed. I don't know. Who knows? So menu items belong to the coffee house. All right. All right. We can do it that way. I'll say it. The composition. Okay. Each drink should track which barista made it. We actually saw this relationship, so I'm just going to put it again. This was actually one of the examples I used, so it was a unidirectional association. There we go. That's a bit of understanding what we need, what our requirements are for the program, what we need to be able to do. The second step is to actually model this thing out. Before we get to actually coding anything, I like to plan things and connect them together so I know how they're going to look when I actually do code them. Plan your system before you actually code your system. It's always good to have a good plan. So for this, for me, I'll use draw.io if I can find draw.io. There we go. And it doesn't matter to me what you use. You can use anything that you want. But I'm just going to use this as a standard UML maker. So this has a lot of different things that you can do with it, but I'm not going to like advertise for them or anything. So you just go down to UML and just, click on a class and drag it there. That's pretty much what I'm going to do with it. It just works. It's nice. You can share things, blah. Anyway, Coffee House. There are other tools like Lucid Charts. And Coffee House will have a name. Should be public probably. But make it named. I'll make it a property. Um, yeah, we'll do that. All right. What else do we want? Let's see. More than a name. Pook. Well, we need menu items, right? That was one thing that we required. Coffee house. Menu items belong to the coffee house, so it has to have menu items. Gotcha. So this one we could probably keep since it's composition. We want to keep this out of anyone else's view. So we're actually going to keep this private. We'll just call this menu items with a camel case instead of uppercase. And we'll make it a field instead of a property. So this will look a little bit weird, but I'm just going to put it like this. And this isn't technically standard UML, but that's because C# came out after UML. In class, we sometimes do it using stereotypes, which are allowed in UML. So we do like that sort of thing, which is perfectly fine. But yeah, the getters and setters and things, that's properties were new. And C# was much newer than UML, so that's the way that one is. Let's see. Drinks made is another one, right? We need to be able to track which barista made each drink, and we want to be able to show all the drinks made. So we need actually some sort of way of listing the drinks made. So what do I want to make with that? Do I want it to be private? Do I want it to be public? I tried to think of access modifiers, but we haven't really gotten to inheritance yet, which is where we discuss all those. So I'm just going to make things probably mostly public at the moment, and just note that that is not a good protection scheme, not at all. Most of the time, you'll want to at least have things at the very least internal, and be able to not have it completely accessible by third parties. That way you can protect it some. There is a principle that we will go over in a future lecture, not today. But I think I will need a private or public. I'll make it public. I'll make it public, and I will extend the length of this rectangle. There we go. And I'll make name a string, so we give it a type. I'm going to make it required, so I'm not going to let it be a nullable string. All right, but drinks made. That's going to be well, that could be the actual drink list of drinks. So we could do it a list of drink. Do we have drink? Yeah, I'm gonna make drink. I think. I think. I'm trying to think of, do I want to make a coffee or do I want to make a drink? Because I could do either and have a coffee be subclassed of the drink, that sort of thing. But I think what I want to do is have it be a drink. Because they may make tea and other sorts of drinks that might not fall specifically under the coffee category. So I will make a list of drink, and I will have menu items be a list of menu items. And here we will. This time since it's a private field, so I'm just going to leave it be. I'm not going to give it a getter or setter. It's just a field. So that's all you can do with that. So we have a string that's a name. The drinks made is a list of drinks. I'm debating on whether I want to make that private currently. I like to make things private when I can, and I think I probably can with this one. I think I can. So I'm going to go ahead, and if we need to open it up, we will. But for now, I think I'll make this private. Um, yes, and then for the methods. Well, let's see. We have what? Add menu item, it said. Add remove menu items from the menu. Make drinks from menu items. Tell which barista made each drink and show all drinks made. So the coffee house itself will be the one that adds and removes the menu items then. So we need something that says add menu item. And that will probably need to be public. So we'll make it add menu item and probably take in a menu item. So do I want to make it just to have a name and a price? Or yeah, I think I'm just going to, well, I could just have it be like that, you know? But the problem with doing that is that right here is where you lose the encapsulation and the composition that we have. So this would pass a menu item in because I'm telling it to pass it to this method. But that's not what we want. This is a composition relationship. In that case, we want the coffee house to be the only thing that creates, manages, or destroys the menu items. So we can't pass a menu item in. We need the coffee house to make the menu item. Instead, we pass information about the menu item. So like a string for the name of it. Maybe the decimal for the price of it. We'll do that simply. That's why I didn't put menu item there though, is because then it wouldn't be a composition relationship anymore. And let's see, go here. And see, what else do we need? Well, show menu is probably an easy one. And that should just tell you, yeah, just be avoid show menu. I don't think I'll need to even take in anything, just show the menu. And that's it. That should be, yeah, pretty well that. And what else do we need? Well, we need to make a drink, as I mentioned. Make drinks for menu items, and we need to show the drinks made. So those are the requirements. So next thing is going to be make drink. Oh yeah, I can zoom. How's that? I can zoom. I can't tell how big some things are. You know, it looks big to me, but yes, I can zoom in just fine. All right. So let's see. All right, we got menu. And the next thing was to make a drink. And we'll do that. And this time we will have it return a drink, make drink. I will do this, make drink. And again, we can't pass in a menu item that we're making. We need like the a menu item name and the barista that makes it. And we'll have it return a drink. No problem. I'm always happy to please. Um, I might have to zoom out a little bit when we get more than one class, but but not too much. Then yeah, so that's that, and I will do one for if remember and not that much. How's that? There we go. And I can probably and probably do this a little bit better. Can I? Usually I can a little bit better. Yeah, it says it's either off or on. Okay. Well, I need to leave it on for the moment, so hopefully this is good enough on the text. But I just need to be able to show all drinks made. All right. So that's the next thing. So I'm going to do just a public show all drinks made. This is not a typical one that you would probably have unless something really messes up or you need to do some taxes. At that point, you might want to do that. And I'm just going to show them instead of giving you a list of them or anything. I'm just going to print it out. And that should do the coffee house. That was all we required. Name, the list of drinks, the list of menu items, and again, we're keeping this specific to the coffee house. We made that private for a reason. We actually made this private too, so we need to get rid of the getters and setter there. Make sure you make these things match. This minus sign means private, and privates don't get getters and setters, not for fields. You typically don't make properties private, so these getters and setters only go for properties. We have a lot of different things that like plus and minus. Plus is for public, minus is for private. We do get into other things, but this is what we want to have for coffee house. Now, the next one I could probably do a menu item next, since that one is created by the coffee house. It's not going to be much of a class to it. It's just going to have a little bit of information. There's not going to be like there's no going to methods. You know, it's not going to have any operations that it does because the coffee house manages that. The coffee house manages the entire list of that. So and you might have a remove menu item at some point, by the way, or update menu item too, but this is all I was required to do because I wanted to make it quick. And that's all I'm going to do. I will go ahead and there's usually an easy way to copy, but I want to try to get you. There we go. I think that mm, sometimes just because I want enough to work with, but I don't really need, I probably should. I don't need anything for the menu items. Menu item and a name. Can make it I'm going to make it internal, which is this one, by the way. I'm hoping I'm not wrong with that. I think it is. Pretty sure it is. Yeah, that is. Yes. Okay, so we're going to make that internal. We can have a getter, but yeah, I don't want to do anything with it other than just give it a name. I want that to be completely accessed by the coffee house. The coffee house still needs a way to access it. So how is the coffee house going to access this? It will look into its list and see whether or not it has a string. And do we want to make it a property or not? That's the question I'm trying to answer now. Is we can have it at least have a getter and a private set. That would make the most sense, which I can use the symbol for instead. Okay, so let's name. Yes, I debate things sometimes. And let's say that we're going to have a price. And again, I'm going to debate this one too, but I think it should all be internal since we're going to have a composition relationship with Coffee House to let developers know don't use this menu item class outside of Coffee House. So this is internal and it's going to be a price with again, and this will be a decimal this time. It deals with numbers in C sharp if you're unfamiliar. Numbers being currency type numbers. Private and private set. And that's it for menu item actually. A name and a price. That's all I'm going to add for the moment on menu item. Let's see. Then we have drink and barista left to go. I think drink's probably easier. It also doesn't really have any. It has one method just to get information about it, and I think that's about it. I think so. All right, so I will go ahead and move you just slightly up, and I'll duplicate. Yeah, I'll duplicate this one. That it's easier to delete than to add, so I'm going to do that. And I'm going to go ahead and make a drink class. Here we go, drink. So, what does drink have? Well, it's a menu item, so it needs to have a reference to somehow having a menu item, but you need to be able to make drinks from menu items, right? That's the interesting thing. So make sure you keep the relationship with both coffee house and menu item composition, but you're going to have some sort of reference between drink and menu item because the drink is part of the menu. So we're going to make that public for this time. Now, drink isn't going to do anything with that. It's going to have a private setter, so it's just going to be able to retrieve the fact that it is a menu item. That's the only thing that we're going to have is the reference for that to explain that. And that is going to be a menu item. Try to get my mouse cursor out of the way too. And then we will do get minus set. All right. So menu item connection is made. And then between baristas, each Drac should track which barista made it. Unidirection association. So unidirectional. So each drink has to track the barista that made it. So I'm going to make that simple, and I'm just going to make it public for this and say it's going to be called made by, and it's going to be of type barista, and we'll have a get, and we can do a private setter if we want. And let's see what else do we want. That I need for the drink. The time it was made, which you can do in different formats. For simplicity, I might stick with string here. If you're more of a C sharp expert, you might just go with time span or date time. But for this course, we haven't gotten to those sort of types. They're more complex. So I'm just going to make it a string and call it timestamp. Yep. Set. Mm, Always thinking about encapsulation. Kind of want to standardized the way I'm doing this. Kind of not standardizing the way I'm doing any of that. All right, that. Okay, that's a little better in my eyes. All right, timestamp should be all we need, except we need to be able to get information about a drink. It's going to be very simple, and so I'll just make it get info. And it's not going to return anything. I'm not going to need anything else. Coke. That is going to be it for drink. The last one will be barista. We can make it below here. How much information does barista have? They don't have any methods except for get info again, which is like drink. They will have a name, and most likely ID. Could drink class be made to inherit from menu item? Now that is something that we would discuss during the inheritance part, but it is something that you could think about. It is something you could think about. Um, Certainly, I would think about inheritance for menu item because, or for drink, because it wouldn't have to have a reference to the menu item at that point, and it's going to have a name, which most likely the drink will have a name, and I didn't even put one there. So that's going to be interesting. But that's why we have menu item there, right? So, and it would have a price. So it would make sense for a drink to have a price, but because it has a reference to menu item, it doesn't need that. I would say it would be a good candidate for inheritance. And I would say that there's probably some good candidates that could be under drink, like cappuccino and lattes and things like that, that would be inheriting from drink itself. And then there would be other things under menu item, teas if you gave them that. And you could also do pastries and things like that. And that would be entire types of menu items. And inheritance is all about types of things. When you say one thing is a more specific type of another, which a drink is a more specific type of a menu item, then you say, okay, well, that sounds like it is actually one of this. This is a type of this thing. So that's inheritance right there. That's what it looks like. That would be my thought. But we haven't gotten to inheritance. So from the four questions, the framework, that you could probably get the answer to say yes, that would be a good idea to make it, and also to have different other types be inheriting from menu item. And that's why we kind of have a very simple menu item in the first place. Most of the time, the parent is very simple, and then you have a more complex children. All right, now back to barista. And I think this is pretty much going to be very similar. I'm just going to think, I don't need menu item, obviously, and I don't need made by, but I do need different properties with different names. For the moment, I'm just going to drag it here, not looking at the other classes. So I'm going to go with barista. Okay, barista. So, well, barista has a name. So name, screen, and we'll just get MI set. All right. So basically, once it's set, this isn't truly read-only because the barista class could have a private member that that would set it afterwards, like could change it. If you want it to be truly read-only, you would not even put a setter, and then you would just add the barista and not ever have their name changed. But name changes happen, so usually having that possibility is a good idea somehow. So that's why we leave at least some way of doing that. Now, it also needs usually some sort of ID, right? Some unique identifier for this barista because baristas can have the same name. So let's have a unique identifier, and that's going to be an integer in this type, which is usually the case. Yes, and again, minus cents. Um, don't need this, but I do need to get info. And I think I want to actually, instead of doing void, I think I do want to, since it says get, it doesn't say show. So show menu makes sense to be a void. Get menu sounds like it's going to return me information. So I'm going to change that to be a string for get info. That way it will make sense with the name. If it was just show info, then that would be a different thing, and just want to make sure I've gotten everything there. Okay, and we can pretty much see all the classes. I'm going to zoom out just a little bit, poke, and move them slightly so we can start to see how we connect these things. Okay, what? Yep, move. There we go. Okay, so what are our connections here? We already know that we have the menu items completely owned by the coffee house, right? And stop trying to do that. I love when I grab things. So we need an arrow going from menu item to the coffee house to say that this is the whole. Poke. If I could put an arrow with this little space. Yeah, about right there. Okay, we need a specific type of arrow. Now for composition, it starts with not this, it starts with a diamond that's filled. I think it's this side. Yeah. So that's how you should denote a composition relationship. And if you want to see, you can actually animate this and see which way your classes flow. So this is also useful. I've found whenever I've drawn things wrong sometimes. Um, so that's one relationship. Now, the coffee house also pretty much owns the drinks as well. So that is another composition relationship. So let's say composition, boop, 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 and we will do you as well with the diamond. And usually you can look through, I kind of know where things are, but there are a lot of different arrows if you'll notice, and they all mean different things. But the most important ones for us are association and composition and inheritance ones. This one, again, composition, drink is part of the coffee house, menu items part of the coffee house. They are composed of the coffee house. Let's see. And then we have drink has an association with barista. I want to move barista slightly down then. Boop, boop, boop. And, and we also need to get barista that doesn't have any association yet. Needs to have an association with the coffee house. They work at the coffee house. So we do need to actually give them some sort of reference to the coffee house. Trying to think of we don't have we don't have any methods to deal with that yet. So like we would normally have something like get barista info from the coffee house or something like that. There's get info from the barista, and right now there's no reference between the two, so we don't have to make the connection if we don't want. But later on, we would most likely want a connection between barista and the coffee house so that their schedule could be made. We're keeping this kind of simple, so we might just leave it off for now and just connect the barista with drinks since that is a reference that we do have. That's the only reference we have between barista and anything else right now. Poke. I love how it just does that sometimes. It's good enough. Okay. And then this is a one-way association. So this should be the flow. Yeah, that should be fine. Now, I could try to straighten it out, but sometimes that can be difficult. So I'm just going to leave it as a little bit crooked. I hope the people that are low OCD are okay with that. And then the final one kind of looks like this. And again, you would most likely, very, 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 very likely have a link somewhere between barista and coffee house. We haven't implemented schedules. We haven't implemented ordering things really. We have added menu items and making drinks, but we pass in a barista. That's the closest we have to a barista in the coffee house, and that's not referenced because that's just going to a method. So there's no type barista here, in other words. You don't see that come up anywhere. So you can see how the connections kind of match, right? We have this menu item, which is fully owned by this, and drinks made are very similar to the menu items because they're type of menu items. And then we have the barista, which is only currently attached to the drinks that they make. And that's fine for now. Okay, so that is step two. And of course, we would want to do more with that, but we have to start somewhere. We have to start somewhere and do it simply. So now we actually have to convert this into code. at least to very simple class structures. That'd be our start. We can do a very empty skeleton, which looks almost exactly like this. And it's why I like making these things, because it's very easy to see how you can get one to one with the code. And so I'm going to make a few classes just over here, new file, and I'll do coffee house. And I'm not putting anything in them yet. I will. Barista, and then there was drink, and then there was when a menu item. That is it. And by the way, I probably should enable my own extensions. I disable C sharp sometimes because I'm writing a book on the C sharp stuff, and if I disable maybe yeah, I have it. If I disable C sharp, then it makes it easier to screenshot my code. Um, but it should start. Yeah, you can restart the language server. That's fine. But you'll have yours hopefully enabled. And it's just that yeah, it makes it easier to do auto like auto indent auto well not it makes the references to things go away whenever I disable them. That's because they get annoying. But now we should be able to make things. Not starting with barista. Well, first of all, definitely the C sharp ones. The official dev kit, the C sharp one. Some GitHub would be nice. GitHub pull requests are ones that I typically use. I don't use a lot of them. You can use theme packs and things like that if you don't like the colors, but I don't use a lot. But you can use VS Code for a lot more than just C sharp. It is typically used for just C sharp though. It's a great language for, or a great IDE for that. Um, but no, I don't use anything beyond the basics really. So there's nothing crazy other than GitHub, I guess. That's a bit about the max. So now, because the barista was one that had like pretty much no connection, nothing else requires it. So I think I will start with that because this isn't going to break anything if I start with the barista. If I start with the coffee house before I develop the menu item, well, then that's going to cause some issues. That's going to cause some issues because we haven't created our classes for that yet. So where I usually start is the one that doesn't require anything. When we start requiring things, well, this already requires a menu item, so I would go to menu item next. And then we know that barista menu item exists, so we could create drink. And then we know that everything exists at that point, so we could create coffee house. So that's the way I like to start so that I don't get a bunch of errors when I'm doing code. And when you get errors in code, it can sometimes try to type things that it doesn't understand that you are going to make a class of that name. I'm going to make a file scope namespace for this, which means I'm going to type the word namespace and coffee house. There we go. Also going to have a class coffee house, but this is going to be our namespace as well. So this is a file scope namespace. That means that the namespace is available for the entire file. That's something C Sharp added. How other? I think they added 11, maybe 11. Yeah, I think so. Um, which wasn't too long ago actually. It used to be that you would have to do that sort of thing instead, but you don't have to anymore. It reduces the amount of indentation, which was always a big complaint that I had, is how much you had to indent over just to have a namespace. There are times where you want to do it when you want to have multiple namespaces per file, but usually that isn't coming up either. So this is what I prefer to do. And I mentioned that the coffee house and things like that or that. Okay, so barista. Barista is what I'm doing. And we'll just make everything public as the classes, except for menu item, of course. And we're going to do that. So you say this is what I was talking about, where it says zero references. If I disable the C sharp engine, it makes that prettier for me to print out for my book that I'm writing. That's the main reason I do that. But it has good syntax and stuff. Yeah, I can get an error already. So, okay. So now we have name and ID, and I made that public with a private setter. So public string name get private set public string ID and not string int ID gets private set. And I think we have to need a constructor of some sort. So I will go ahead and get a public barista. It will stop complaining about the name not having anything since we're going to require it name and we're going to have an int ID that's passed in. And we're going to have a little bit, not really, I don't think I'm going to do much with it. Now, it'll say that you can do this easier in C sharp 12, I think it is. They either added this in 11 or 12, and I forget which. But yeah, yeah, we need to set things name equals name and ID equals ID. It's actually not going to be yellow. It's going to be these three. This will say use primary constructor. Now you can, but it's a newer feature, and a lot of people haven't looked at that. I will upload everything, so don't worry. I don't know if I can't really upload things to Twitch, or I will create a folder somewhere for links on YouTube, I think. I'm not sure how much I can do on Twitch. I can do more on YouTube, but I will definitely upload to It's Learning. But as I was mentioning, this right here says you can use a primary constructor, which was added like in, I'm not going to look completely up, but I think it was 11 or 12 in C sharp. And it just makes it simple when you are going to set the name and ID, like these properties only. If that's the only thing you're going to do with the constructor, then you can do it in a simpler format. But that's the only time that really comes up. And most of the time, you still want to use this format. So I don't want people to actually forget this, especially my students that are here. I don't want you guys to forget this format because that's the most used format that you'll have. That's not going to go away just because there are primary constructors. That's not meant to replace them or anything. So that's what I typically don't do. All right, so that was that. Now it said menu items next. And we can do namespace. And then we can do this because it will already say because I now have a namespace coffee house, it realizes that. And so I can, just do namespace and then that, which is what I usually do. It's like I usually hit tab a lot instead of typing a lot. Name equals name and star 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 equals name. Let me see. Let me go back to barista. Okay, so this name is being set to what's being passed in. C sharp is a case sensitive language. So this name here is the property for the barista here. It's being passed into the constructor through this. So when you make a new object, a barista object, then you have to pass it a name and an ID, and those come in through the constructor. Then that gets set to the actual property name, big case name, big case ID. It's case sensitive language, so this is different from that. The uppercase is different from the lowercase. That's what it means, though, is that when I do create a new barista, this is stuff that's going to be passed in, and they're going to be set to these properties here. That's all it means. I hope that cleared that up. Okay, so back to a menu item. I think I have around somewhere. And we'll do this one as an internal, which I was mentioning. Internal. Yeah, I'll type that. And I will do I think for menu item, a public string name it was, and I'm pretty sure it was a public get and a private set, which is why I've made most things. So yeah, I bet. Okay, and then a public decimal and price and bits and private set. And then we'll need a constructor for menu item that takes in the name and the price. So at that point, we would do public menu item for constructing the object from the class. That's why it's a constructor. String name decimal price. There we go. We're just going to set the name equal to name and price equal price. Oh, now that you don't want to do. Poor rice either. Whole rice. There we go. There we are. You could do that, but it gets a little bit more complex, and really you should have these just lowercase. It makes so much more sense and makes it simpler too. Okay, and then when I do upload things, I'll have comments on the code instead of just it being simple like this. But let's do a bit of a sanity check on our barista real fast, just to make sure that it looks like what we actually set out to do. Now we have a string name that has a public getter, private setter. String name, which is a public getter and private setter. An int ID with the public getter, private setter. Int ID with the public getter and private setter, and then I didn't do get info, so I should do like a get info for barista. Then we will need a public string get info. I'm going to make this an empty method. That's what we're doing right now, and that should be okay because it's yeah. It's going to okay, so it's got a few things it wants to do, but I need to return something like Um, return null string. There we go. Just so it doesn't give me an error. This says that I'm going to return you a string, and it complains if I don't give it a string. So I'm going to give it an empty string for now. And then I need to do the same, most likely. Checking anyway for menu item. I don't think menu item had anything that we did with it for the UML, but we'll check. Menu item, just no name, string, public getter, or not public, but internal getters. Actually, they should be internal. This is why you check things. These should be internal, and technically they would actually be internal, even if I didn't put that there, because this can never be higher precedence than what you have out here. You can't say that this is going to be internal, but that's going to be public inside. It has to be internal or less. So it would have interpreted it as so. But just because it makes more sense, and any developer that looks at your code would be like, why did you not make that internal instead of public? That doesn't make any sense. Um, it's a good communication strategy. All right, so these were internal string name and had private setters, and yeah, and then we're good. And it had internal getter. I should have said internal getter. All right, so that one is all internal. Good. Internal is not a middle point. It is the second point down from public. It can do almost every single thing that public can do except be used by other assemblies, which means other third-party developers typically. So it's almost as unprotected as public is, except that it contains it within your own sort of several projects or whatever you've got on with your own assembly. We don't have time. We don't have time to discuss assemblies right now. Um, but um, but think of it as not being letting third-party developers access it. So that would be the easier way to understand it. So it does everything that public can do otherwise. And so it's not as a middle point. The middle point is typically considered protected between private and public, if you want to know. Even though there are closer ones, I think, than that now that they have like 7 or 8 of them. All right, so I checked that, and now we get to create our drink. Since we have a menu item and a barista, we can create this now. All right, back to drink, which is empty currently. And coffee house. I hit tab a lot. Like I said, I just hit tab. I don't really type a lot of characters. Then for drink, I do want that to be a public class drink. No, that's it. Drink. She might wants to lowercase that guy. Okay, there we go. And then I believe it was they have a menu item, they have a barista, they have a timestamp. Yeah, menu item made by timestamp and get info. Public with private setters and a public method. So public menu item, and I can call this menu item. I think I can do that. Maybe I can't. Maybe I can't. Maybe give me a sec. Let's see. Can I not call you menu item because you're not named? No, it's not because of that. It's what did I not give you protected from? All right, so you are public class drink. Yeah, you're within this namespace. Oh, it's because menu item is actually internal, so we can't make it public because it's internal. It can never be public. That was the whole point. And then we have to make that into our. We can't make barista public. Barista made by get with private setters, and then public string and timestamp. And again, you would probably want to use like a time span if you're more familiar with that, or date time. But I'm just going to use a simple string. And then I'm going to have a constructor, and that's going to have a menu item, and a yeah, I don't need to actually pass in the timestamp. I can actually create the timestamp in the method whenever I do make that barista. And we are going to have barista. And we are going to set menu item, menu, and then we're going to set, what do you not like here, by the way? What have I done? Oh, did I make you, yeah, because I keep thinking that I can make that. It's because you can never make it public, ever, ever, in any way possible. Internal. It would have to be internal. There's no way that it will ever let you make menu item public because I told it it was internal. So no matter what, now I can't export this drink, even though I've said that, hey, this is a public class. Here, we can't ever create it by a third party. So because this is meant to not be messed with by third parties. That's why I made it like that. So that's what it's complaining about. And I was mentioning that there was this nebulous connection between drink and menu item that we probably should have defined a little better. Barista, or maybe it's made by equal barista. All right. And not get rid of my clothes there, but okay. Then public string get info, and we will return. And that should be okay. What have I got? Oh yeah, timestamp. I have to set timestamp to something. Um, I'm just going to say, I'm just going to do this real fast. Um, Something like that. This is what you might want to do. Basically, it's a type of date time that gets the current date and time, and then it turns that into a short string. So that's just something that you learn over time. Very simple little function, but you have to know it exists. That's the problem. You have to get used to knowing all this exists. But that was an easy way just to set timestamp. And that should set everything with drink up. Now, the barista is set. I want to make sure we have a coffee house is left. That's what's left because we did menu item, internal and everything, which is why we had some problems here. And we did everything but coffee house, which is more complex. And the coffee house has, now this is why we're keeping this private, and that's private because we're having complete control. So we do have a lot of methods this time, but we don't have a lot of properties. We have one property and two fields. Name, public, just a purely public name of the coffee house. There's no reason not to make that public, what your coffee house name is. Newspaper, copy, and public class, and we'll do coffee house. Yes, I know it's the same as the namespace. That's okay. And we will do a string of some sort. Let's see. What string? What was it? Name. Public string name. Cute. I wanted to do exactly what the what the UML said, but they're very very close. And then over here we will make sure that we have what was I going to do? Oh yeah, fields. I like to put fields first, private. And we have a field for a list of drinks made. List of drinks made, and private list of menu items, please, what I called them. Yeah, and those are our properties. Now we do need to make a constructor for this thing that's going to have some information. Um, so don't really need to do anything but pass in in the name. So let's go ahead and do that. I will do a public coffee house and then string a name. And since these lists are private, I do need to give them some memory. All I've done is say, hey, there's going to be some lists at some point. Now I'm going to actually say, here's some memory for those lists. So I will say drinks made equals, and this is the newer format for doing this. There's also the older format, and then there's the older format, all of which still work. But this is the way you do it now. This was like 9.0, this was before 9.0, and this is like 11, I think, maybe 10. And that's drinks made, and then do the same for menu items. It's just a very simple way of initializing a list. And then I need to make sure name is the name. There we go. We shouldn't have too many complaints with that. It may say that, hey, it can be removed because we haven't done anything with it. That's because we haven't made any methods. We haven't we haven't done anything with these lists, so it's like, why are they there? So yeah, of course, they're not going to be useful until you do things with them. We do have several methods. We have show menu, which is a void. We have add menu item, which is a void. Make drink, which returns type drink, and show all drinks made, which shows them and returns a void. So I usually like to start with the voids first. I'm going to just do show menu. And again, I'm not putting a lot of functionality into this yet. That's not this step. No, that's the next step. And we will take a break after I get these methods in. Let's see. All right, so I will need to do public. Let's do them in order. Void add menu item and string name and this decimal price, I believe is the other thing that needs for menu item. Menu items only have names and prices, so that be what I need. Okay. And again, I'm not going to put the functionality in. I only do that when I have to, when I return something. And then we will put the functionality in after we've already planned this out and made sure that we match up and everything. And then the next one will be public void show menu. And the next one, that was easy, will be public and void show drinks made. And the last one, I believe it is. Yes, it's the only one that actually returns something. Drink. And this is going to be make drink. Drink menu item name, I think it is. And we need a barista that makes it. Baristas make drinks. Think that's all I need for that. I do have to return something, so I would just say return new drink. Or return. Can I do that? No, I can't do that. Probably do new group. Yeah, let's do that. Should be able to do that. I have to give it. I have to actually give it the menu item name. And yeah, barista. Now, what did drink actually require? Menu item name. Yeah, I was wondering what my thing needed here. I actually need a menu item for my constructor. Oh, to make a drink, I have to actually use the constructor which had menu item. I probably should just use menu item name instead, but you know, I didn't, so that's that. Instead, I will use the menu item name, and there will be a function to solve this issue that we'll get into. But we basically just need to find the menu by the menu item name. So instead of doing that, I will just say, and I probably can't even do this, but I'm going to try because it's, yeah, it's not going to let me because it is, yes, it's the internal. So it's going to be a little bit difficult to do this one here without it making it internal as well. So if I made that internal and then turn that into, say, a menu, I don't really want to make a menu item, but I kind of have to just to do this one little thing. Equals, and this is not going to be related to anything. I'm just doing this so that it doesn't crash. That's the only reason I'm doing this whatsoever. Yeah, I don't even think I can do an initializer because it can't. Um, I have to give it a name and string and decimal. Okay, menu name. We can at least do that, and 0 would be price. Okay, I don't think I'm curious if I can make it public. Yeah, it let me, so we'll do that. And this required a menu item. So we create a new menu item with that name and a 0 price just to make sure that this doesn't crash. And that's all. That's the only reason I did this. This is not the functioning code. This is not the end code at all. These are meant to be mostly empty. That's the whole point, is to have these empty to show that we have corresponded with the UML diagrams. Because if we didn't correspond with the UML diagrams, then either our diagrams are wrong or our code's wrong. And we need to figure out which one. So for our coffee house, we already checked barista and we already checked menu item. We're just going to check drink them over here. So check drink. We have now, so we had to make that internal because there's no other way. You can't make that public. All right. And then everything else I think is fine. Public with private getters. Yes, that's all correct. Made by timestamp public with private getters, just like you see here, just like you see there. And then get info just returns null string right now, but it does return a string. That's matches. And we've already checked the other two, so the only one left to check is coffee house. Okay, so for coffee house, we have two private lists, drink made and menu items, which are of type drink and menu item. Yep, got those. We have a public name right there. And we have methods of add menu item, show menu, show all drinks made, which are the void ones. Add menu item, show menu, show drinks made, void ones. Then the slightly more complex make drink, which returns a drink. And so that is this one. And it gives you in a string and barista that made the drink. And that just makes sure that it doesn't crash. There we go. So this is placeholder code. That's all. We now have matched our diagrams with our code. So that is the next step of this. We're going to take a nice little 15-minute break since I've been talking forever here. But yeah, I'll make sure to comment everything and upload everything and all that. But yeah, so we will take a break and I'll be back. This will be a, I don't know, 15. I'm not sure how much my long break does. So if that does like 25 minutes, that's bad. So I'm just going to do a short break. I forgot. I'm not sure how long. I can check real fast actually. How long is my long break set to? Yeah, I can set to 15 though. I'll set to 15. It'll be silence because Twitch doesn't like my music for that. But let's take a nice little break. Let it give some time. Here we go. There we go. All right. So I want you to notice one thing here with the UML diagram now that we are back in action here. So all the UML diagrams are supposed to show the relationships between every other thing that we have, right? So for instance, we have a relationship between drink and menu, or drink and coffee house. That's shown, right? Drink, coffee house. We have a relationship between menu item and coffee house. Cool. Those are good. We have a no relationship that's just a part of coffee house, so that doesn't need anything. And similar for barista, it has a relationship, but only because of drink. So drink has a barista and also a menu item. And the only reason we don't have a line between drink and menu item is because we have not made it to inheritance. That's literally the only reason. This should be there technically because this is not the best of relationships to put because we've said that they do have a relationship. I don't know why I did that. We've said that this has a relationship, but we've also said that menu item is controlled completely by coffee house. So we've kind of made that untrue by adding it as a drink. And the reason we've done that again is because a drink is a type of menu item. So we're only going to do it that one time, and when we get into inheritance next time, we'll factor that out. But the fact is, right now, we would worry about our life cycles and be like, why is this relationship not drawn? This is when you would go to your, boss and be like, hey, I don't understand my requirements here because this doesn't match up. You said this is the only thing that controls menu items. Yet here it is in drink, and drink doesn't have a line here. So what's going on with that? So that's when you go to the stakeholders and try to figure out things or figure out if something that you have modeled yourself is done incorrectly. I did this on purpose because we haven't gotten to inheritance, but it was astute for Troublemaker 47 to point out that drink should be really a type of menu item. So we're only going to do it this one time, and we're going to remove that reference next time for sure, because this should have the only control over menu items, and drink should be a menu item. So that's why there's no line there, even though there really should be. Okay, so we actually need to implement some of these methods now and things. I think we could probably start with the barista since all we have is this get info method. So this is step the 5, I think it is. Yeah, we now need to just implement the logic. We did the understanding the problem, we did the modeling, and we converted to class diagrams. I guess it's step 4. Now we just need to implement the logic of the methods. So we need to return something other than null string here. And for this, it's a very simple string. We're just going to print the name and ID for get info, saying it's for their employers or maybe for their own information. I'm going to use string interpolation to make it easy, meaning I can put expressions within the mustaches or braces, if you want to say. These I've been seeing these called mustaches lately. I don't know why, but I still call them braces and brackets. Braces for these, brackets for the other guys. These. And then I want ID colon and ID. It just lets me print the expression right into the string, and it doesn't require me to take extra memory by concatenating strings, which is it's a process that if every time you add a string to another string, you add up memory every time you do that, just because of the way strings are stored, if you didn't know. And that is Barista. All it does is return the name and ID, basically. And what else do we have? Okay, so there's Barista, and what was the next easy one? Drink should be an easy one, actually. It's we already did the timestamp part. I did that on my own. All right. So the only thing there, again, is get info. So this time, it's going to say the name of the item and who it was made by. So here we will do this for string interpolation, and $ precedes any string interpolation if you're wondering, and that lets you do that. So it escapes out braces. New item, name, and made by, and that's going to be made by. That's just a barista, so we need a name. There we go. Made by, and I don't think I need to put in. Yeah, we can put the timestamp there. Well, we could just use our. We don't need. We can do the get info. We can use that method instead of doing that, because then the barista will print the full information that they have, and that would look actually a little bit more detailed at timestamp. So that gets a little bit more information than just the name, right? Gets the ID as well. So this was made by this barista with that ID at that timestamp, and that string, because the only thing we're doing right now are the behaviors, and so don't have any behaviors here. Barista's done. This one has behaviors. That's where we gotta go next. It's the coffee house. So let me see. What do I want to start with? Coffee house. I think add menu item is probably an easy one. That one we know about lists, so all we have to do is add to a list. So first, I'm not going to put too many comments just to keep things simple and fast. But in my finished version of the code, there'll be lots of comments. Only coffee house and create menu items. And this is where we say menu item. And new item is fine. Equals new, and it needs a name. So I'm just going to pass in the name and price directly from what we do with add menu item. And then menu items dot add, and we're going to do new item. There. We just add to a list by the add command. That's pretty easy method right there. All right, so that's an easy one. Most of these are kind of easy actually. Show menu. Well, we're just going to do a simple console.writeLine. Console.writeLine to print to the terminal. Dollar or console if you want to say. Item dot see. Yeah, we need to actually get the items. Okay, so we do have to do a little processing here. And I haven't shown you how to do that in class at all. And for the people that are not in my class, you probably don't know either. But there is a thing called a loop, and the loop repeats code in blocks. So within these braces, a loop will repeat sequence of actions. For lists and dictionaries and collections like that, a for each loop is the easiest loop to use. And I'm going to go ahead and use a for each loop, which just has me say, okay, I need to have some sort of menu item here, and I'm going to loop through all the menu items in existence in the menu items and find the one with the right name, because that's what I need, right? Because I just need to print out every single one. So all I'm going to do is print it. So to show you, menu item and item in menu items. So now we can access it by just the item. That just creates as a temporary variable that can be used within this for each loop. And this for each loop will continue until it's done processing every part of this collection. So collections are good with for each loops. Collections are like lists and dictionaries and things like that. So now we can do the console.writeLine. And that point, I'll do another string interpolation because I like those. Iam.name, and then I can do iam.price, and I will format this as currency is what that format. You can format it as certain different things. Currency is C. That's all I need to know about that. and semicolon at the end. I'm going to put a prefix to this and just say the menu at the coffee house, basically. So I'm going to do a console.writeLine before this loop, and this is going to say, I'm going to do another one too, just a blank line, and then I'm going to do menu at name, and that should get the name of the coffee house. So the menu at the coffee house has these items with that name and this price filtered as a currency. So that you'll be seeing for each loops quite a bit with the lists and collections and like dictionaries. And we're going to probably have another one soon because we need to filter through some things. I got add, I got show. Show drinks made is more probably it's probably about the same complication, I think. Let me see, did I make any complication to that one? Yeah, it's the same thing, basically. Yeah, this I can copy and paste this code actually, and then just change a couple of things because instead the menu items we're looping through, we're going to loop through the drinks, right? And then of course this isn't a menu item anymore. And then of course this isn't name or price anymore. We just need to change that to at that point just get info. And I think that should be enough. But the get info is already formatted, so I don't need any special formats. That should be fine. And then instead of menu at, I'll say drinks at. Reuse code when you can. And when you see things like this, you may see like easier ways of doing it when you have multiple things like that. You could pass in a variable type or something, but this is an easy way. So there's another for each already. And it just was changing the menu to drinks instead. That was a very simple change. So now we've got something that showed the menu and to show the drinks made. We do need to actually make some drinks. That's one thing I need to do. If I've done that, make drink. Yeah. So to make a drink, we're passed in the name of the item and the barista who's made it. We need to find that. So I'm going to put a comment there just to say what we're doing. Find the menu item with this name. And I think that's fine. That's find the menu item with this name. That's all I want to do. So we need the for each loop again, and we're going to loop through the menu items. So again, it's just for each menu item. And by the way, if you don't want to type menu item, you can type var, but this is fine too. Because var will know what it is. But it's sometimes good to be explicit like this when you're first starting out in menu items. No. So, okay. Now we are going to see another statement here. This is going to be called an if statement. And what we're going to do is try to find the an item with the name that's passed in. So we need to check two things against each other. And we do this with an if statement and a comparison operator. I'll show you how. We'll see more of these later on. If item dot name is equal to, and this is a comparison operator. Does the thing on the left equal to thing on the right? Menu, item name. Does the currently processed item, the name of it, does it match the item name that was passed in? Yeah, you can have everything, don't worry. I'll make sure to, I'll get you everything. So does the item name match with what was passed in? And this two equal signs means comparison. One equal sign would be assignment instead of comparison. And so we need to create a drink, a new drink with the found menu item and barista. That should be good. Okay. drink, new drink equals new. And then we pass in the item and the barista. All right, so now we got a new drink, and then all we have to do is return drink. I believe that's all we need to do. Should be able to return drink there. Can we not? Oh, new drink. Not the type, but the actual name of the variable. Okay, that should be fine. And what if it's not found though? Well, at that point, you would probably return null. So I guess we should have made this a possibility of having null. And in C sharp, that means we have to put a question mark here. That allows it to be able to hold this value that is no value, the absence of a value. So if it doesn't find something, we need to still return something because it's still expected a drink, but we'll just return null. And we need to update, we need to get rid of all this stuff that was placeholder code. And we need to update our diagram to make sure that we make this nullable. So let's update our diagram. And that was in the coffee house. And we made the list of drinks. That was fine. There was a drink question that we're giving back. So that is a nullable string, meaning that I don't want to say that. I save things so often. There we go. And that should allow us to hold null. Now, if you didn't want to do that, you could have returned a drink with like an empty name or with no barista or something. But this makes the most sense when it doesn't actually find the item in the menu that's passed in. Then there was probably some sort of problem entering the name. Then maybe you typed it wrong, basically. You could have had a typo, or maybe the menu's changed and it no longer exists. So there was that. Okay, so let's make drink. Am I missing any of them? Show drinks made. Yeah, because I didn't really done there. Yeah, I did show drinks made. I did that. Okay, I did make drink. Show menu. Add menu. I think it's all. Okay, that's all of them. Okay, so that is all of them. And just to parse through a little at a time, all we did for get info was print out string interpolated variables, name and ID. For menu item, we didn't do anything. There's no behaviors. For drink, we did something very similar to the barista, but we used their get info method to print out more information. So we have the menu item's name, we have made by the get info, which calls this and gives us the name and ID, and then it gives us the timestamp it was made at. There we go. Then the last one would be coffee house, which had the most behaviors, which makes sense. It's our coffee house is our big main hub for information. So we have the adding of new items, which just creates a new item and adds to the list. Show menu, which we showed using the for each by processing over all the menu items. We printed out each name and price formatted as currency. Show drinks made was almost exactly the same, except it uses the list for drinks made and it used the get info property because there's no price and things like that with that one. And with make drink, that one we had to do a little bit more effort because we had to find the name or item with the name that we pass in. And we had to check it to make sure that it actually is in there. And when we find it, we create that new drink. And then we finally return it. Those are our requirements, and that's what we did. So that is it for the coffee house. Now we need to actually get everything to work together. We need to test this thing. So I'm going to this program.cs, which we haven't done anything with other than put our requirements on there. And now we can probably get rid of that part and just say the requirements instead. And we need to like show that this stuff works, give it a test, you know? So let me see, do I have something for a test? I think I do have something decent for a test. Yeah. So let's create this we'll just create a public class program. By the way, if you have any questions at any point, you can stop me. I'm perfectly fine slowing down and explaining. So the first thing I'm going to do is create a new coffee house. Then I'm going to add some items to the menu. Then I will show the menu. It's easier if I just put the comments first and then show the code. And then I'm going to create some baristas and make some drinks. And um, it does. Yes, actually, thanks. Not sure what we've done if it since it's everything is in that other namespace. I'm not sure what we may have tried to put it in there, but it shouldn't have been able to access anything. Technically, you don't have to. What it probably would have done, and I'll show you. It probably would do this is have coffee house dot that. So it would ask me to do that every time. The namespace is so I don't have to do that. That's the main thing. It's just an organization construct, not really any crazy programming thing. It's just a organizer by folders, basically. Make some drinks and show all the drinks made. I think that's so. That's kind of what our requirement said, right? We all right. We add some items. We show the menu. We make some drinks, show the drinks. So we first need to create a coffee house. We can create a new object from a class using the new keyword that calls the constructor. So I'm going to make a new coffee house with, and I'm just going to call this shop. I don't know. Maybe I could call it, there we go, Java Joy. Sure, why not? Equals new coffee house. Yeah, you don't even have to do that. That's old. And I do need to give it some information though. You see, I want some information. It needs a name. I need to give it a name, which I'm just going to call it Java. Boy, why not? And just to give some debug statement, I'm going right to the console while I'm doing. And if I can do that without like messing everything up. First of all, I didn't type that right, but what have I done here? Oh yeah, we can't just do this in a public class program. You have to do this in a method, by the way, and that's where our main method comes in. The main method is the very first thing that your program will look for. So we need we can say public static void main, and you can define it a lot of different ways, but this is the easiest way to define it. And it has to find this and then run the code there. It doesn't just run code in classes, it runs the logic in methods. And main is our main method, so it needs to run the logic there. This is where our program starts. It will look for every class you have until it finds main. That's why it's static, because that makes it very quick to find main. Now, we can save what the next thing is. So that right line. Let's say adding menu items just to give us a progress on that. And then we will say java joy.add menu item. And how about a latte? And how about, I don't know, we're going to go with what? Like, I don't even know how much it is, so trying to even think. Pay so often with the card, I don't even look anymore. It's kind of bad. You know, um, I'm just making up numbers, so seems reasonable, I think. And there's no, I haven't given it any specific denomination. That's up to you. And The decimal, though, is most likely necessary no matter what your local pack is. I think that will still be required. There might be extensions to where you can convert that to a comma, but most of the time, decimals in computers are actually stored as points, and you can blame Americans for that one. All right, there we go. And there we go. So now, the next thing is Java join.show menu with semicolon. Every single statement has to have a semicolon. These are method call statements, and this one is an assignment statement. Assignment statement, method call statement, because it calls the method write line. This calls the add menu item. So there are different types of statements that you watch out for, return statements, and just know to put a semicolon after them. In C# anyway. Not every language, but C#. So create some barista. So I'm going to say that's what I'm doing. Probably should do that for the previous thing too. Create some baristas. And I will go ahead and say showing menu. It helps with debugging. If you get stopped at any point, you kind of know which point it gets stopped at because you just printed to the console at that point. So that's why I'm printing that information out. It's not necessary. Oh no, Emma. How about Emma? I haven't seen Emma in a while. New Emma, and we'll say one. Let's give you the idea of one. First employee, Emma. Welcome. Welcome to Java Joy. Rista and Magnus. Yes, we'll give it Magnus. Goes new. And Magnus, and welcome to Java Joy Magnus. We actually have to probably hire them at some point, but that's later on. All right. Then we need to create some drinks. We'll say that's what we're doing. Creating some drinks. Okay. Then we'll actually make some drinks, and we will say make drink. We're going to say a latte, and Emma made it. And then we'll do another drink and just put some information in. Cappuccino, I just spelled that correctly right there. And we'll say we'll just to alternate, and we'll give a third one, and we'll say espresso, and then we will say Emma, just to make sure that things out of order will work fine. I like to test edge cases, like different orders. Like you could try this versus that to see if there's a difference. There shouldn't be, but you need to test everything. And then console dot write line showing all drinks. And of course, Java dot show drinks made. And there. All these were method call statements. And then I guess that's all I'm really doing. Just we can put it in a loop or something if we want to do anything else, but I think that's what I want to do for now. If we want to give like a menu or something like that and say, hey, press a key to do something else. But we might want to, sometimes the terminal does exit, it exits on its own. And you can say, I don't want that to happen with a simple like read key or something like that. So I'll do that just in case there are some watchers out there that have weird consoles, not really weird, but different consoles. Um, that like to close without giving information. And then you have to press a key to exit at that point. So there we go, another method call statements. And that's the entire main. All we did was create a new coffee house, named it Java Joy, add some menu items, a latte, cappuccino, espresso with different prices, showed the menu, create a couple baristas, and then add some drinks that they made. We show the drinks they made, and we say exit. So let's see if any of this works. That's going to be the question. And let's see. For VS Code, it's .NET Run. How much did I break? Oh, okay. Let's see. Okay. Create a new coffee house. Okay. Well, it doesn't really say anything when you create the coffee house, but it did. Adding menu items, showing the menu. Okay, so here's the menu. That's the first thing that actually shows something. So the menu at JavaJoy is a pretty decent format. And actually, it's printing out in my local currency. That's kind of funny. So we'll print it out in your local currency like that, but you have to put it in like the decimal point format. It may not on your terminal either, depending on your settings. It may print differently, but that's kind of interesting that it did this in my local currency. Creating some breezes, creating drinks. We don't have any drinks at Java Joy, so it says show all drinks. We didn't have any. There's the problem right there. So what happened? Creating some drinks. We made some drinks. Showing drinks. Show drinks made didn't do anything. So we need to find out what's going on with that. And let's see. That would be in the coffee house. Show drinks made. What did I do wrong? Drinks at, and didn't I find a drinks made is not null there, no. And it did not find, I guess, any items whatsoever, or the get info didn't work. That's the only two options that there could be. Either there are nothing being stored in drinks made, which, let me see, do we ever add to drinks made? No, we don't. See, we make a drink, but we never added it to the drinks made. So that's the problem. We need to do that. When we make a drink, we have to add it to the drinks made. Drinks made dot add and new drink. There we go. And that should fix that problem. I will clear and try that again. And there we go. Yeah. And you just trace problems like that. Just logical things, really. You have to get used to that sort of thing. I saw where the problem had to be because it wasn't printing out, and that's why we did all those debug statements. It wasn't printing out any drinks. So, I looked and saw that, well, this was calling show drinks made right after that. So that had to be the method that had the problem. So what was up with that method? So I looked at show drinks made, and I'm like, well, okay, it seems like it should be printing all the drinks made, but there must not be anything in that list because it's not doing this. And so why isn't there anything in this list? My next logical leap was that I never added anything to it. So the place where I add to that list is in make drink. And that is happening right here. So that's where I need to add. And that's how I debug things. Is just go step by step. What's happening here? This looks okay, but why is this not working like this? And just keep tracing until you figure it out. And it doesn't take much. You can do more statements if you needed, but that was a very easy problem to fix. So, but yeah, we can say that okay, they met at 11:52. I didn't put any. I guess that's I guess it's 11:52. But okay, the class ends at noon. If I don't know how many people are from my class and how many are not, but class ends at technically noon, so I'll probably just call it here, and I will make a collection of things over the weekend. I'll probably get some rest because this was hard on me with the virus still in my system. Um, yeah, but I did manage to get through. Thankfully, my voice got better as it went along. I didn't cough anymore, so that's really good. I'm getting closer and closer to being over with all that. So I hope you enjoyed. Hopefully, you learned some things and saw some things that I did wrong and saw some things I did right and saw some things you could do better. That's all it is. This is just learning and just trying to solve problems. This is the entire object-oriented programming is about solving problems. And that's what programmers do. That's what engineers really do. And that's what engineers use is object-oriented programming. So there's going to be a lot more of these coming up because of the train tracks being worked on, requiring me to be much later than I thought was going to be to make it to class. So these live streams are sort of taking that and putting them into a format where people can be there and ask me live questions and things. This is the most interaction I've probably had with you guys since the beginning because yeah, I haven't been able to because of the times of the train, but this is in a way an advantage. So now we get a little bit more time with each other, even though it's not the personal time I would like to have face-to-face time. It would be very nice, but unfortunately, because they're working on the train tracks, there's nothing we can do about that. So thank you for being here. I will see you during next class. Well, see you. I will hear from you in the chat or whatever, or on the forums, and I will make sure to comment out my code well and post everything that you've asked for. And thank you very much. Yeah, so I think there's an ending thing. All right. Have a good day, night, afternoon, wherever you are.